In this guide, why a token that's valid at every API is a security liability. How RFC 8707 lets clients declare exactly which resource server a token is for. What the resource parameter looks like on the wire. And why audience-restricted tokens are now a recommended baseline in OAuth 2 deployments. Identity Expert, powering you to be an expert in identity. Today we're covering resource indicators for OAuth 2, defined in RFC 8707. Here's the problem in one sentence. You request an access token, the authorization server mints it. That token is accepted by every API your authorization server protects, even the ones you never intended to call. An attacker who tricks your application into sending that token to the wrong API succeeds, because the token carries no information about which server it belongs to. RFC 8707 closes this window. It lets clients declare, at request time, exactly which resource server a token is for, and the authorization server mints a token that only that server will accept. Think of a hotel room key. In most modern hotels, a key card is encoded for one specific room. Put it in the wrong door and nothing happens. But imagine a hotel where every key opens every room on your floor. A guest who gets hold of your key now has access to your minibar, your luggage, and anything else you left there. That's a bearer token without audience restriction. Any service on your authorization server accepts it equally. Resource indicators work like a key cut for a specific door. When you check in, you tell the front desk which room you need. The key they program is scoped to that door only. Even if someone copies the physical card, it will not open a different room. In OAuth terms, the resource parameter in your authorization request tells the AS which API this token is for. The server mints a token with an audience claim locked to that API's URI. Any other API that receives the token checks the audience, sees the mismatch, and rejects the request immediately. Let's make the threat concrete. In a standard OAuth deployment, a single authorization server often protects multiple resource servers simultaneously. A payments API, a user profile API, and an admin API. Without audience restriction, a token issued for the profile API is structurally identical to one issued for the payments API. Both carry the same issuer, the same signature key, and the same expiry. The only difference is intent, and intent is not enforced. This is what the security community calls a confused deputy problem. An attacker who can trick your application into presenting a token to the wrong API through a rogue redirect, a misconfigured client, or a phishing page gains access they were never authorized to have. The scope parameter restricts what operations a token permits. It does not restrict which resource server the token is valid at. RFC 6750, the bearer token spec, documented the audience confusion risk. It provided no solution. RFC 8707 provides the solution. A mechanism for clients to name the target resource server at the moment they request a token, and for authorization servers to enforce that name as a hard constraint on where the token can be used. Resource indicators work in 3 moves. First, the client adds a resource parameter to the authorization request. The value is the canonical URI of the intended resource server. For example, https://API example.com. You can include multiple resource parameters if you need a token accepted by more than one server. The authorization server stores the requested resource URIs alongside the authorization code it issues. Second, when the client exchanges the code for a token, it includes the same resource parameter in the token request. The authorization server validates that the requested resource matches what was authorized. If the client tries to expand the resource set at token exchange, asking for access to a server that wasn't named in the original authorization request, the server rejects the request with an invalid target error. This prevents scope widening at token exchange time. Third, the authorization server mints the access token with an audience claim, the AUD field, set to the requested resource URI. The resource server validates the AUD claim on every incoming request. If the AUD does not match the server's own URI, the token is rejected regardless of its signature or expiry. A token minted for the payments API fails at the admin API. The cryptography is valid, the audience is not. Here's what the HTTP actually looks like. The authorization request is a get to the authorized endpoint with standard OAuth parameters plus one new field, resource, set to the URI of the target resource server. If you need tokens valid at 2 APIs, include the resource parameter twice. The authorization server redirects back with a code tied to those resource URIs. The token request is a post to the token endpoint. Grant type authorization code, the code, and the resource parameter again, this time locking in which API this specific token targets. The authorization server returns a standard token response. But when you decode the access token JWT, the payload carries an AUD claim equal to the resource URI you requested, for example, https://API example.com. The token is now audience restricted. When the client sends this token to the API, the resource server decodes the JWT and checks the odd claim against its own URI. If they match, the token was explicitly minted for this server. If they don't, the resource server returns a 401 and includes an error of invalid token in the www authenticate header. Cryptographic validity is not enough, the audience must match. Resource indicators neutralize three concrete threats. First, cross-resource token misuse. An attacker who steals a token minted for the profile API cannot replay it at the payments API. The payments API checks the odd claim, sees the wrong audience, and rejects it. The token signature is valid, but audience restriction makes that irrelevant. Second, confused deputy via redirect manipulation. If an attacker can manipulate your client's redirect chain and trick it into presenting a token to a malicious endpoint, that endpoint cannot relay the token onward to a legitimate API with a different audience. The odd mismatch stops the relay at the legitimate server. Third, resource scope expansion at token exchange. A misconfigured or malicious client that tries to request a broader resource set at the token endpoint than was approved at authorization time will be rejected. The authorization server stores the resource URIs bound to the code and compares them at exchange time. Any expansion returns invalid target. One important caveat: resource indicators restrict where a token can be used. They do not restrict what the token can do within that resource server. Scope still controls that. RFC 8707 and your scope policy work together, not as substitutes for each other. RFC 8707 was published in February 2020 and has seen steady adoption. Keycloak, OAuth 0, Okta, and Azure Active Directory all support the resource parameter. OAuth 2.1, currently in draft, treats audience restriction as a security best practice and references RFC 8707 as the recommended mechanism. The OAuth 2 Security Best Current Practice, RFC 9700, explicitly recommends that authorization servers issue audience-restricted tokens and that resource servers validate the odd claim on every request. FAPI 2, the financial-grade API security profile, requires audience-restricted tokens for high-value operations. Combined with DPoP or MTLS for sender constraining, audience restriction forms one of the two mandatory token binding layers in FAPI 2. If you are running an authorization server that protects more than one resource server, RFC 8707 is the mechanism that prevents a token from one API from being silently valid at another. Without it, every stolen token is a skeleton key. Next on Identity Expert, dynamic client registration, how OAuth clients can provision themselves without a developer ever touching an admin console. Subscribe so you don't miss it. All primary sources cited in today's guide are listed on screen. You'll find direct links to the RFCs and specifications in the video description below. If this breakdown helped you understand the topic better, please subscribe to Identity Expert. We publish a new protocol deep dive every week. Thanks for watching. If there's a specific identity standard, authentication flow, or security protocol you'd like us to cover next, drop it in the comments below. We build our content based on what the community asks for. Subscribe and hit the bell so you never miss an episode.